If you shrunk Earth, would it make for a good billiards ball? This question comes to mind based on the popular claim that relative to its diameter, the Earth is actually smoother than a pool ball. But is that even true, and does that even matter? If you use the tolerance requirement stated by the World Pool Billiard Association, which is that all balls must be 2.25 inches plus or minus 0.005 inches, the math checks out for even the most extreme difference on Earth, measuring from the peak of Mount Everest to the deepest depth of the Mariana Trench. However, many people have pointed out that this tolerance is for the roundness of the entire ball, not for local smoothness. To get a better idea of how smooth a billiard ball actually is, you need to look at the surface of an actual ball. That's exactly what Dr. Dave at Colorado State University did to analyze this popular claim. Looking at a 1mm by 1mm section, he measured 0.86 micrometers from the peak to the valley of one of the blemishes caused by imperfections in the manufacturing process. For a similar section on Earth of about 140 miles by 140 miles, a unique terrain to look at would be the stretch from Death Valley to Mount Whitney, which in case you didn't know also happens to be the same region as one of the craziest ultramarathon races I've ever heard of, the Badwater 135, where runners start 280 feet below sea level in Death Valley, the lowest elevation in North America, in the middle of the summer, and run 135 miles straight to Whitney Portal, which is at 8,400 feet of elevation. There's also a few peaks in between, so it's a total of 14,600 feet of vertical elevation gain. The world record for this race is somehow 21.5 hours, a pace of around 9.5 minutes per mile, which is absolutely wild. Anyway, I'm getting distracted. Measuring from Mount Whitney's peak to Death Valley and dividing by Earth's diameter, you'd find that this region would be much rougher than that of a billiard ball. That's for a pretty unique circumstance, but even for less interesting places on Earth like Illinois, the Earth would still be slightly rougher, although it would be smoother than a scuffed ball that has been knocked around quite a bit. That's for the smoothness claim, but to tell if an Earth pool ball is actually playable, it's perhaps even more critical to look at the roundness of Earth and compare it to that original listed tolerance. The Earth is about 27 miles wider in diameter at the equator than at the poles. That might sound like a lot, but Earth is 7,926 miles in diameter at the equator, meaning it would fit those original requirements for roundness laid out by the World Pool Billiard Association. So if it fits the roundness requirement and most of the ball would only be as rough as a badly scuffed one, I think my conclusion would be that an Earth pool ball is at least playable, and if you ever just barely miss a crucial shot, well, at least you can blame Mount Everest. Thanks for watching to the end, and I'll see you next time.